Hey folks, this is Captain Jones here to talk to you about programming basics. Today, our objectives are threefold. We're going to ultimately give you the tools to be able to write short machine code programs for the LC3 that do, semi-useful things. Along the way, we're going to describe the process of systematic decomposition, which will teach you how to take a problem statement and slowly break it down into all the way into the machine instructions that you need to be able to solve that problem. And we're going to create sequential, conditional, and iterative constructs using LC3 instructions. So let's get started. Okay, so recall from our previous lesson, we have this sort of pyramid of abstraction. And as we move up the pyramid, we sort of abstract more and more. You can imagine that as we move down the pyramid, we're effectively decomposing. We're taking kind of an abstract thing and breaking it down into its constituent parts. And so today the goal is to start with something like a problem statement, which is sort of at the highest level of abstraction, and then start to break that down into ultimately the machine language that can run on the hardware of our LC3 computer. So the technique we're going to look at today, which is one of many techniques for decomposing a problem, is a flowchart. A flowchart describes a procedure or an algorithm. An example of this might be a cooking recipe, which lists sort of step-by-step how to bake something or how to make a meal, or a tax form, which is a government document that shows you, tells you which numbers to enter based on your income for a year, a given year, and based on the values, how to calculate the taxes that you owe. So a flowchart uses three elements to kind of control the flow of this program, i.e. the flow of this procedure. The first is sequence, a sequential construct, which is equivalent to just being able to state that one piece of code follows another. The second is a conditional construct, which is something you're probably already familiar with. It's the equivalent of an if-else statement in code. Sequence looks like this, which is to say that a part of code follows from another part, one right after the other. The condition looks like this. When we get to this point in our flowchart, we are testing some condition. If that condition is true, then we execute subtask 1. If it's false, we execute subtask 2. And then either way, at the end of either of these subtasks, we continue on with our flowchart. So this would be an example of an if-else statement. You can imagine a couple of permutations of this that do if-else or ifs by themselves. And then we also have iterative constructs that implement effectively either a for or a while loop. And so that kind of looks like this in our flowchart. Again, we're going to come into this box or this diamond here to test the condition. As long as the condition is true, we're going to execute our subtask and then move back to the retesting the condition. If at any point the condition is false when we test it, then we exit and continue on with our loop. So in the parlance of the LC3, sequence is relatively straightforward. That is to say, we just have, we put machine code one after the other. So you can see in this diagram here, I've got memory addresses A through B, B plus 1 through D. And the fact that the first subtask occupies memory higher up, that puts it in this sequence first. And so of note is that if we have a construct where we are sort of looping back to some part of this code, we have an arrow coming in here, then that loop or that label will refer to this memory location, the very first instruction of our second subtask. Our conditional statement in LC3 now requires a branch statement. So anytime we see this diagram or this diamond in our flowchart, that effectively means we're going to have to generate some kind of branch instruction. So to execute this or to implement this in LC3, we're going to write some code that generates our condition to test. And then here at memory location number 2, we're going to issue a branch instruction. And we're going to branch such that if the result of this condition is true, then we jump down to subtask 1, this instruction here. And there's nothing at the end of this because after subtask 1, we just are going to continue on with our code. If that condition is false, then we immediately start executing subtask 2. When we get to the end of subtask 2, we execute an unconditional jump to the bottom of subtask 1 to continue on with our code. And here you'll notice that X and Y are the number of instructions that we're skipping. So in this case, if our condition is true, we're skipping over subtask 2 and this instruction. So X is effectively the number of instructions that exist right here, or memory address C minus memory address B. Y in this case is skipping over subtask 1, so it's going to be D minus C effectively. Okay, to implement iteration, we're going to perform a very similar process where we start by generating the condition that we're testing. In this case, we are going to configure our branch instruction to jump if the condition is false. That's going to represent this branch up here. So if the condition is false, we're going to skip over our subtask to underneath this last branch instruction and continue on with the rest of our code. If it is true, then we want to execute our subtask, so we won't take that branch. We'll execute our subtask, and then the bottom of the subtask is an unconditional. We'll jump back to the top of this section here where we regenerate our condition and retest that. So again, Z and W are lengths of instruction, number of instructions that we're skipping. In this case, Z, we're skipping over the subtask plus this branch instruction. So the total number of instructions here is the value in Z. W here has to be a negative value equal to the number of instructions in the subtask plus this branch instruction plus the generate condition. So that takes that would hopefully take us all the way back to the top here. The goal of this, actually I think what I want to do is, we'll do this first and then I'll come here. I'll say the goal of decomposing our problem in this way is so that we can ultimately describe a problem solution to entirely in LC3 machine code. So we can take something like perform multiplication or count the number of characters in a string and compose that problem entirely in machine code. So that requires some iterative problem solving, meaning we are going to effectively start with a very simplified flowchart and break that flowchart down into sequential steps or into iterative steps until such time as these squares of code to be executed, these diamond conditions to be tested, can be implemented directly in LC3 machine code. And so you can see an example of that in the book if we go to section 6.14. You can see we're gonna try to solve this problem where we're counting characters in a sequence, and we start with this very basic flowchart that has this description of what we want to occur in this block. And clearly this is too high level. We can't implement this in LC3 machine code. So the authors start by breaking that problem down into 3 steps. We're going to sort of initialize some stuff, then we're going to perform the actual work, and finally we're going to display the result. In that case, the first step, initialization, is simple enough that we can kind of go ahead and directly implement that using some LC3 instructions. But the part in the middle is not. We break that. We add this iterative step to test if we found the end of our string that we're searching, and then we further break this down and also the output down into additional steps that here can get we implemented with direct LC3 instructions. And actually, if you go back to where is it? Section 5.5, you'll see that the flowchart we just derived almost identically matches this flowchart here, which is the actual machine code that we use to implement this program. Okay, so to summarize, when we start programming, we are effectively moving down this pyramid of abstraction. We're trying to take a generic problem statement and decompose it into the LC3 machine code that will actually implement that program. So that requires some iterative problem solving and sort of decomposing that problem into steps that ultimately are equivalent to LC3 machine code. And the tool that we're going to use to do that is effectively the flowchart. The flowchart has 3 basic elements: sequential, conditional, and iterative, that allow us to define which code executes after one another, i.e. the sequence. If we want to implement some sort of if, elif, else statement, or some sort of for while loop, then we can use our knowledge effectively of the branch instruction in order to kind of skip around our code to be able to implement these constructs. Okay, today's quote is brought to you by James Gentleman Jim Corbett, who said, "Fight one more round. When your arms are so tired that you can hardly lift your hands to come on guard, fight one more round. When your nose is bleeding and your eyes are black and you are so tired that you wish your opponent would crack you one on the jaw and put you to sleep, fight one more round, remembering that the man who fights one more round is never whipped. I'll see you next time.